Welcome to MooMooMath. Today we're going to look at 45, 45, 90 triangles and the special rules. Okay, remember that a 45, 45, 90 triangle is an isosceles, which means two sides are the same, and it's right, which means you have a right angle. The angles, the two acute angles, are 45-degree angles, and those, let's go ahead and mark those as congruent. Okay, we're going to have two cases. You're going to solve these triangles without knowing any other side but one side, and you can do that because there's some special rules. So let's look at the rules of 45, 45, 90. If you know one leg, you actually know the other leg, because remember, this is isosceles, so these two sides are the same. And there is a ratio that all you need to do is take one of the legs and multiply it by the square root of 2 to get the length of the hypotenuse. So you can always write this also as x and have the square root of 2 after it to keep it looking kind of mathematically correct. Okay, so the two legs are the same, and the leg times the square root of 2 gives us the length of the hypotenuse. So let's look at what I call a forward problem and a backward problem. Okay, the first one's a forward problem, which is really easy. If we know that this leg is 7, well, we know this leg is 7 because it's isosceles, and the ratio says I just multiply this 7 times the square root of 2 to get the hypotenuse. So it's just simply 7 square root 2 for the hypotenuse, length of the hypotenuse. You could actually plug that into the Pythagorean theorem, but it would simplify down to the same answer. So it's just a quick method to solve these. Okay, now here's the backwards problem. What if you don't know the two legs, but you do know the hypotenuse? Well, since the rule is you take the leg times the square root of 3 to go from the leg to the hypotenuse, to get the hypotenuse backwards to the shorter leg, we're going to divide by the square root of 2. So I'm going to take 12 and I'm going to divide it by the square root of 2. Now you can't have a radical a square root on the bottom of a fraction, so I'm going to rationalize that by multiplying it by the factor of 1 and as a square root of 2 over square root of 2. That's really just 1. Square root of 2 times the square root of 2 is equal to the square root of 4, which is 2. And then I have on top 12 times the square root of 2. I can't multiply those together, so I just stick them next to each other. And then let's divide the outside coefficients. 12 divided by 2 is 6, so that simplifies to 6 root 2. So that means each of these legs is 6 square roots of 2. Okay, so there's a forward problem where you multiply by the square root of 2, and here's a backwards problem where you divide by the square root of 2. Hope this was helpful.